given the time constraints, we'll skip it. So what I would do is rewrite this as dy dx. And then separate the variables. Now I'm going to integrate both sides. Too late! Too late! You have to pay a $30 fee to get back in. 30 to each of us.
You just had a quiz right now, right?
Yes.
Yes.
2 of them. 1 for each. So, on the left side, I'm integrating 1. But what's the variable? So instead of writing, right, if you integrate 1, the question is, well, what do you write? X? Y? Z? That's the purpose of this. Right, that says, oh, it's x plus an arbitrary constant. On the other hand, if I'm integrating 1, I can write 1, and it's dy, then I write y plus an arbitrary constant. So here I'm going to write y equals
X cubed over 3 plus
1/3 x cubed,
x squared over 2.
1/2 x squared. And instead of writing an arbitrary constant for each side, we'll just add the 2 arbitrary constants together at the end. So this is nothing new. This is what you've done your entire career. It's just that they only wrote this part. They solved the left side for you, and that's what they gave you to do. But you've been doing differential equations since you started to integrate things. You better remember that.
Mm-hmm.
Test 1.
Yeah.
We didn't have to solve that differential equation. We just wrote down what the solution was. What did somebody remind me what the solution was?
KT, yeah. Y0. Why not?
Well, now we're going to prove that that's the equation. Dy dt, variable separable. I'll put the y over on the y side and put the dt over with k. Separated the variables. Now let's integrate. The integral of 1 over y, L in absolute value y, equals
K
plus an arbitrary constant. We don't need the absolute value here because y, remember, is a population amount or something like that. So we can ignore the absolute value. Raise both sides as powers of e. So I get y equals e to the kt plus c. But we add exponents when we have e to the kt times e to the c in that fashion. What do we get when t is 0? Well, then we get what we call y sub 0 equals 1 e to the c. And what we'll do is call this c1. And we'll say that e to the c1 is just some other number, call it c. Now let's substitute in. We've got y equals e to the kt times e to the c1, and we've got that e to the c1 is y sub 0, or c, or call it whatever you want. I guess we'll just call it y sub 0. That's what we called it up here, right? The initial amount, and that is where the differential equation came from. So y is y0 e to the kt. Wasn't that fun? Glad you guys enjoyed yourself. So I will go back and talk about 9.1 and 9.2, but I thought it good to go right to the section from which you will have a homework assignment. So 9.3.